This video is going to do a quick review of Pythagorean theorem and overview the process of how to use it. So in your journal, if you're in my class, we have this bright yellow foldable. These 4 tabs that go over the Pythagorean theorem in general, steps on how to find a hypotenuse or the letter C, steps on how to find a leg or the A or B, and then the converse of Pythagorean theorem or some common triples of right triangles. When you open the first tab that said Pythagorean theorem, we're going to label, I'm going to zoom in, we're going to label these blanks. It says A and B are the legs. C is the hypotenuse, which is always the longest. We've talked about that. C is always the longest line. If we back up, we could color code these. A and B, remember they go together to form the right angle. And then C is the line that's always opposite the right angle, or it's the diagonal line. When you open up the second flap that said how to find a hypotenuse, we are going to fill in these 2 blanks as well, and then this last little line. The hypotenuse, remember, is line C. Then the 2 lines that are connected by the right angle are our legs, and it doesn't matter which one is A and which one is B. So to work that out, we would, first line, we would square them. So 6 squared, 8 squared, and that makes 36 plus 64. After you square them, you would add them, and that would be 100. And then last, you would take the square root. Square root of 100 is exactly 10. So then I would say my missing side length now is exactly 10 because it was a perfect square. When you open up the third tab, it said how to find a missing leg or how to find a leg. On this one, we still have our hypotenuse over here, connected our 2 legs, connected with the right angle. The first step is still square them. So I have 25 squared and I have 7 squared. And that's 625 and that's 49. After you square them, you would subtract them because we already know the large side. When you subtract them, it's 576. And then the last step is, again, take the square root. The square root of 576 is also a perfect square. It's exactly 24. So then my missing side right here would be 24. If you open up the last tab where it says common triplets, Pythagorean theorem triplets, you can test out any 3 numbers to see if it forms a right angle. And some really common ones, the most basic starting out combination, 3, 4, and 5. This is our basic one, and we can build off of this. So multiples of 3, 4, and 5 that are combined together would make a right triangle. So for example, the next combination would be 6, 8, and 10. Then I could do 9, 12, 15, and so on. Okay, I could keep doing the multiples of 3, 4, and 5. Okay, there's other combinations that can go together. Another combo that does fit the rules of a squared plus b squared is c squared is 5, 12, and 13. Another set is 8, 15, and 17. And one other one for you to know is 7, 24, and 25. Now there are other combinations, but here's just 6 of them for you to know. But again, like I was saying, this is a really basic common one, the 3, 4, 5 combination, and then multiples of that. These 3 that's listed over here, I could also do multiples of 5, 12, and 13. So for example, I could just double these 3 numbers and make it 10, 24, and 26 would also work. Then I could double this combination right here and have 16, 30, and 34. Okay? Now, the other thing that we haven't talked about, converse of Pythagorean theorem. I can identify if a triangle is going to be right, obtuse, or acute based on the way that the triangles add up together. So what we know is if you have a squared plus b squared, if they equal c squared, then that forms our right triangle. If a squared plus b squared is less than c squared, then that's going to make an acute triangle. And the last one, if a squared plus b squared is greater than c squared, that makes an obtuse triangle. So you can test out any numbers and see what's going to happen, if it's going to fit a right triangle, an acute triangle, or an obtuse triangle. Okay, so we're just going to look at a couple examples to know if it's going to be an acute triangle or an obtuse triangle or a right triangle. So I'm still going to go at this the same way. Remember, the longest side is always going to be C. The other 2 are A and B. Okay? Longest side is always C. The other 2 are A and B. So on the left side, 6 squared is 36. 8 squared is 64. That's 100. Okay, then I would see 20 squared is 400. Okay, so now the A and B side, they add up to be less than C squared. So this is an example of forming an acute triangle. On the right side of your paper, 12 squared and 15 squared. So 12 times 12 is 144. Then 15 times 15 is 225. And then I want to figure out, is it more or less than 18 times 18? So 18 times 18 is 324. When I add the A and B together, it's 369. So 369 compared to 324, that's greater. A squared plus B squared this time was greater than C squared. So this would be an example of obtuse triangle. And then just like we've done before, if they equal each other, then it's a right triangle.